This is the Unit 3 B and C review for Mrs. Sather's AQR class. Hopefully you have your Unit 3 BC recovery review with you so that you can follow along with our problems. All right, the first couple of things on this page, we're looking at histograms. So what you see right here is a histogram talking about length of Greek tragedies in words. So someone went through and counted all the words in many, many Greek tragedies and wrote the word count there. All right, so question A, we want to know what would happen to this histogram if the interval width or the bin size was doubled. So in case you're not sure what a bin size is like the distance, like from here to here, the part that I highlighted, that would be a bin size. So each one of these little things right in here, this is called a bin. So then the width of that is about 1,000. So this bin goes from 9,000 to 10,000. So we have a bin width of 1,000. All right, so what we want to know is what would happen if we doubled the bin size. So that basically means we're going to take each of these, and instead of doing 1,000, we're going to group them in groups of 2,000. So that would be one group from 4 to 6. This would be a second group from 6,000 to 8,000. There would be a third group from 8 to 10,000, and then there would be a fourth group that goes from 10,000 to 12,000. Now I realize that over here there's nothing in that space, and that's okay. It still has to be in a bin because we have this little piece right here that needs somewhere to go. So what would happen, our question to part A for this particular graph is that the bin size would be 2,000 and we would have 4 bins. Our next question for part B asks us what would happen to each histogram if the interval width or bin size was cut in half. So now instead of going from 4,000 to 5,000, we're going to cut that in half and go from 4,000 to 4,500. So if we took each of these bins and cut them in half, like so, we want to know how many bins would there be now. So we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 little sections. So we would have 14 bins, and each of those would be at a width of 500. Just in case you weren't sure what I did when I was counting, you can always take the number of original bins that you had, which was 7, and if you cut those in half, well, 7 times 2 would be 14 different bins. Our next question is to find the approximate mean for each histogram. So what we need to do on this problem is figure out how many of our books or how many of the Greek tragedies have specific kind of ranges of words. So what I would do is go through here and kind of write little numbers on here to figure out how many were there. So in this first bin, it looks like there were 2 in that column. The next bin, it looks like there were 6. Third bin had 2. The next bin looks like there were 9. The next bin looks like another 6, and then we had a 5, and then we had another 2. We also need to go through each bin, and we need to find a number that's right in the middle. So this first bin goes from 4,000 to 5,000. I would say a good number right in the middle would be 4,500. You can do that with all of the other bins. And in just a minute, we're going to put all of this into an equation so that we can find our mean. I've jumped ahead a little bit and labeled all of those. So now we have all of the bins with a nice number in the middle. So I have a 500. And what we want to do is try to find an average. So whenever we find the mean, we need to find like a total for like how many words all together are going on in this histogram. So what we're going to do is take our first bin, which had 2 items in it, and we're going to multiply 2 times 4,500. Then we're going to add that to the next bin that had 6 things in it and multiply 6 times 5,500. And we'll continue doing the same thing with the next bin. We're going to do 2 times 6,500. we'll end up doing 9 times 7,500. We'll do 6 times 8,500. We'll add that to 5 times 9,500. And then we will add that to 2 times 10,500. And if you put all of that in a calculator, you can pause this for a second if you're trying to compute that. Whenever you're finally done computing, we have 229,000. So 229,000 words. That's going to be at the top of our division problem. So then what we need to do is go through and figure out how many tragedies did they actually count. For the divisor to my problem, what I need to do is add up all of the little numbers that I have here. So that's why I wrote these numbers on top, so they were easy to find. So what I want to do at this point is add 2 plus 6 plus 2 plus 9 plus 6 plus 5 plus 2. Whenever we finish adding all of those together, we should end up with something like 32. So now I've got one more math problem to do. I've got the 229,000 divided by 32. So if we put that into our calculator, we will get an answer like 7,156.25. You can either leave your answer like that, or since we're talking about words, you really can't have a fourth of a word. So it would be perfectly acceptable to round this off to 7,157 words on average for our Greek tragedy. Now we're ready for the second histogram. What I would suggest at this point, so that you could practice, I would pause the video now and go through and answer questions A, B, and C again, just like we did in the first example. I'm going to stop for just a moment, and I'm going to write all of our answers to this histogram down. So if you don't want to see them yet, you want to work, pause the video, and then whenever you start it up again, your answers will appear. So these are your answers. For A, the bin size would be 20 because we're doubling in this time. So it used to be 10, so if you double that, that's 20. And then we would have half the number of bins. Right now there are 8, so then there will only be 4. For part B, the bin size would be 5 if you cut it in half. So then you would have twice as many bins. So instead of 8 bins, now there are 16. As for part C, whenever you do that long division problem, you end up with about 74.2, or 75 students who took, or not 75 students. Wait a minute, that wouldn't be students. That should actually be, we could just keep it at 74.2. I read that problem just a little bit incorrectly. That's a 74.2 average on the test. So in this case, a decimal would be just fine, with a 74.2 average score. Moving right along, now we are starting to talk about a box and whisker plot. So with a box and whisker plot, the first thing you need to do is put all of the numbers in order. The numbers you're seeing on the screen right now are the same ones that are on your worksheet, but this time I put them in numerical order. I started with 10 and went all the way through 50. Went from the left side to the right side, and then I kind of ran out of room, so I started a second row. Alright, so we're looking for a 5-number summary, and that consists of 5 numbers. The first thing we want to know is the minimum for the data. So a minimum, the smallest number that is here is going to be a 10. So that's first. Alright, we also want to know what the maximum is. So that's the second easiest thing to find. The maximum is going to be 50 for our data. Right. We also need to find the median. So at this point, I'm going to write that in. And we need to find the number that's in the middle. Now if we count how many numbers we have, we appear to have, let's see, 2, 4, 6, 8, 10, 12, 14. There are 15 numbers. So the number that's exactly in the middle is our median, and that is 26. All right, so when we're doing box and whisker plots, I'm not actually making the plot this time, as it's not really going to help us with our test. The plot is fine. Maybe we'll do that some other day. But right now what we want to do is find the first quartile number, and we want to find the third quartile number, so Q1 and Q3. So what we're going to do is we're going to find the median of the first part of the data. So we're going to start with this lowest number, and we're not including the median, we're just going there in the middle, that top row. Let's find the number in the center. It appears that 18 is our middle number. So Q1 is going to be 18, the number in the middle, the top half of the data. We can do the same thing with the bottom half of the data. If we go from the maximum down to just before the real median, we can count and find the number in the middle. It looks like 47 is the number in the center of the data right there. So there we have it. For the purposes of this online retest, I'm not going to have you draw the box and whisker plot because that would be a little complicated to do on the computer. But what you do need to be able to do is to calculate the minimum, Q1, the median, Q3, the maximum. You also need to know what these mean. So, if we look at our data, this little piece right here, that's from the minimum to Q1, that's 1/4 of the data. If you look at the amount of data from Q1 to the median, that's also 1/4, and you can see down here we can split this into fourths. So if you're asked, well, what do the quartiles tell you? Each quartile divides the data into fourths. The next part of this reteach is focusing on the definitions for bias statistics. So a bias statistic is statistics that are not quite correct because there was some kind of a problem that usually happens during the data collection process. So here are some definitions. The first one is response bias. So response bias is when a participant intentionally or unknowingly provides incorrect information. So this happens if a person lies and doesn't want to give you the correct answer for some reason, or it could happen whenever a person is just guessing at the answer to a question, such as how much money did I donate to charity last year? They might not exactly know, but they're giving you a good guess because they're trying to be a good participant, but in the process they don't exactly get it right. That's a response bias. The opposite of that is a non-response bias. So a non-response bias is what happens when people refuse to participate. So they know you're standing there, you ask them, would you like to take a survey? And they say no. Or they ask you a question, or a question is being asked of the participant, and the participant says, I refuse to answer. It can also happen if somebody calls your house and the person refuses to answer the phone because it's an unidentified number. Those could all be some kind of an example of a non-response bias. The observer effect. This is when a participant changes their behavior or response because they are being watched. So this happens if somebody knows that someone's checking up on them, and so they decide, hey, I don't want to answer the question, do you smoke? You know, maybe if you're answering questions in front of your mom, you don't want to say, yeah, I smoke. Or maybe if you're in front of a little kid, you don't want to answer a question like, I use alcohol, because you don't want the little kid to get the wrong impression of you or whatever. Or maybe you just think the surveyor is really good looking and you don't want them to get a bad impression of you. So anytime, because someone else is watching and the person taking the survey is afraid of perception, they change their behavior or they change their response so that they will look more favorable to the observer. Wording of questions. This is what happens when questions have leading or misleading vocabulary. So these are questions that try to get you to say something based on just the way it's worded. Such as, would you like to make more money? Well, yes, of course, who wouldn't like to make more money? I mean, I don't know anyone who's like, yeah, I've got enough, right? So if someone asks, would you like to make more money? The answer is going to be yes. And then that's when someone can try to give you a pitch so that you can sell some great new product. Here, join my team and you can earn more money. Yeah. So anything that leads someone to give a certain answer, could be a wording of questions bias. A non-representative sample. This is what happens when the sample does not accurately represent the population, such as if you wanted to get the reaction of people at Turner for maybe a homecoming theme, and you only survey 50 guys. You didn't get any female input on that. So that would be a non-representative sample because we know R.L. Turner has lots of girls and they would like to give their opinions. Undercoverage is also another thing that happens, and this is when the sample is too small. Unlike the non-representative samples where the sample is kind of skewed, where you don't get people who actually fit your whole population, undercoverage is just you go out and you take a sample that isn't big enough. You don't ask enough questions of people. So if you've got a population in a city of 100,000 people and you only survey 25 people, that's severe undercoverage because you need to get a bigger sample in order to get the right data. Sampling just a couple people doesn't always do it. So now that you've got the definitions, this will be another great time to pause the video, take a few moments, and try to answer the questions. The 6 questions that are listed right here and that are listed on your paper, they are examples of each of the 6 things that were just listed in the vocabulary. So take a minute, pause this video, and see if you can answer them yourself. Alright, take a look at the answers and see how you did. For letter G, the 95% of people answered no to the survey question, do you support Barack Obama's plan to get Medicare to fund a new bloated entitlement program, would be wording of questions because the words new bloated entitlement program are leading people to think it's a bad idea. The next one about Megan shopping at the clothing store, she takes a survey, she answers all the questions even though she does not recall the specific details. That would be a response bias because she's giving information that's not correct. The question with Jacob, he's at the library with his mom. He responded he had never cheated on a test when in fact he cheated earlier that day. That is an observer effect because his mother is watching. He changed his answer and is not honest. When Katie walks past a table in the cafeteria set up for a student survey, she chooses not to participate. This is non-response bias because she chose not to participate. She did not respond. Jose wants to conduct a survey to decide which new snack to add to the vending machine at a high school. He gets distracted and only asks 5 people to take the survey before he needs to make a decision. This is undercoverage. Only asking 5 people out of a whole high school what their opinion is not enough input. And if a survey is being done to see which activities students would like to see at the post-prom party, of the respondents, 46 were male and 11 were female. This is non-representative because there were about 4 times as many males answering the survey as there were females. So hopefully this has been informative and you should have your paper filled out. You are now ready to go take the Unit 3 B and C test. Good luck.